We will discuss MapReduce. So MapReduce is a processing model for parallel data, and we can use it to analyze massive scale data. There are two phases, one is map and the other one is reduce, and it is written in a functional programming style. The input data to map will be reduced into phases in the form of a key value pairs. The runtime systems are large clusters built in commodity hardware, and the runtime systems take care of tasks such as partitioning the data, scheduling the jobs, communication between nodes in the clusters. And it is easier for the programmers to analyze such large scale data without worrying about the tasks and how they are being partitioned and scheduled. So the data is read from a distributed file system, partitioned among a set of computing nodes in the cluster and sent to the nodes as a set of key value pairs. The map tasks process the input records independently of each other and produce immediate results as key value pairs and is stored at the local disk. And then finally we need to combine the tasks to perform the final aggregated value. So here in this we can see the input is being divided into map tasks, and in each task you will have to load the data. Then map is the process that will be happening on the actual data, and you can have a local sort, and after sorting similar data can be combined and then you can write it in the local disk. So you will have, for every map you will have an output. Then in the reduce task you need to combine and merge all the outputs written in the map. So first step will be to merge and then combine them, and you have to sort it. So you will merge and you can combine by after sorting, and then again you have to combine. After you combine you will have the final write, which will be returned the final output. So the MapReduce program takes a set of input key value pairs and produces a set of output key value pairs. The best example will be the word count program. MapReduce programs take advantage of locality of data and the processing that takes place on nodes where the data resides. And the data is moved to the computing nodes, which results in significant of data transmission and between the nodes in a cluster. MapReduce programming model moves the computation to where the data resides. So data is not moved, the computation is moved to the node where the data resides. So this is the data flow. First step is map, then you reduce, and then finally you have the output.